Voyager probes transmit alarming data from the depths of space. Voyager 1, NASA's most distant spacecraft, continues its voyage through uncharted regions of the universe nearly 5 decades after its launch. Recently, scientists have been puzzled by the unusual and unsettling data it's transmitting back to Earth, raising concerns of a possible malfunction. Join us as we delve into mysterious signals Voyager is sending during its delicate journey through deep space. Since the dawn of time, humanity has been fascinated with what lies beyond our planet. A curiosity that led to the launch of groundbreaking missions like Voyager 1 and Voyager 2. Interestingly, Voyager 2 was actually launched first, taking off from NASA's Kennedy Space Center on August 2, 1977. Voyager 1 followed shortly after, launching on September 5, 1977. Though it launched later, Voyager 1 eventually overtook its twin, thanks to differences in speed and trajectory. On December 15, 1977, Voyager 1 passed Voyager 2, beginning its historic mission as our farthest-reaching explorer. Each spacecraft weighs about 720 kilograms, roughly the size of a small car. They were launched during a rare planetary alignment that enabled a gravitational slingshot effect, allowing the probes to swing from one planet to the next with minimal fuel. By 1978, Voyager 1 was 265 million kilometers from Earth, transmitting a wealth of images back home. In January 1979, it began a remarkable 108-hour mission, capturing 3,750 images of Jupiter's rotation and producing a time-lapse film of 10 full spins. In February, it passed through the Jovian moon system, and a month later, it discovered Jupiter's faint ring system. Voyager 1 also detected 2 previously unknown moons, which were later named Thebe and Métis. Its next major milestone was Saturn. Precise planning ensured a safe flyby, avoiding collision with Titan, one of Saturn's largest moons. During this phase, Voyager 1 discovered 4 additional moons, Mimas, Enceladus, Tethys, and Dione. Following the completion of its planetary objectives, NASA officially transitioned both Voyager probes into the interstellar mission. By January 1990, Voyager 1 captured one of history's most iconic images, the family portrait of the solar system, while 6 billion kilometers away from the Sun. This image series included 60 photographs, though Mercury and Mars were not visible due to technical constraints. Shortly afterward, its cameras were shut down to preserve power and memory for its long journey ahead. Aside from Voyager, NASA also operates other interstellar explorers, including Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 surpassed Pioneer 10 as the most distant spacecraft on February 17, 1998, and continued its relentless journey for another 14 years. On August 25, 2012, Voyager 1 officially crossed into interstellar space, though NASA didn't confirm the milestone until 2013. By November 2018, both Voyager probes had exited the heliosphere, with Voyager 2 entering the interstellar medium as well. Today, Voyager 1 is approximately 145 billion miles, or 550 million kilometers, from Earth. Despite being so far from home, it has continued to send back invaluable data that no other mission has been able to match. For most of its 45 years in space, the spacecraft remained remarkably healthy. However, more recently, scientists have begun to notice strange anomalies in its behavior. Voyager 1 is now transmitting puzzling signals that even NASA's top engineers are struggling to interpret. There's growing concern that Voyager may first be uncertain of its own location in space. Yet, there's a surprising twist. Normally, Voyager is programmed to either enter safe mode or trigger an alert if it veers off course. So far, it has done neither. Its high-gain antenna, responsible for sending data back to Earth, still appears to be functioning properly. However, the information it's transmitting has recently become unclear and inconsistent. Despite this, the interstellar probe seems to be operating normally, receiving command from Earth, executing them, and continuing its scientific observations. Still, the data from its explanation and control system doesn't accurately reflect what's actually happening on board. According to an official NASA statement, each Voyager spacecraft, including Voyager 1 and 2, carries a 12-inch gold-plated disc containing sounds, images, and greetings from Earth, essentially a time capsule for any intelligent extraterrestrial life that might encounter it. These include 35 Earth sounds, 115 photographs, 90 minutes of Western music, and messages from former U.S. President Jimmy Carter and former UN Secretary General Kurt Waldheim, recorded in 55 languages. Although some have speculated that the spacecraft may have been taken over by aliens, researchers have firmly dismissed these theories. Voyager's operation heavily depends on its attitude and orientation control system, which keeps the antenna pointed toward Earth and manages the spacecraft's positioning. Interestingly, engineers monitoring the situation believe the system is still functioning correctly, adding to the mystery of what's really going on. Crucially, none of the spacecraft's built-in safety protocols have been triggered so far. According to Susan Dodd, Voyager 1's project manager, this mystery is entirely unwelcome. The spacecraft has now been operational for around 45 years, far beyond its original mission lifespan. Dodd also acknowledged the engineering team now faces tremendous challenges in diagnosing the issue, primarily due to Voyager 1's incredible distance from Earth, about 145 billion miles away. This vast separation introduces severe limitations. A physical repair mission is completely out of the question with our current technology. Voyager 1 is traveling to the farthest reaches of our solar system and deep into interstellar space, putting it beyond the reach of any spacecraft we could send. Because messages travel at the speed of light, it takes nearly 21 hours for a signal to reach Voyager 1, and another 21 hours for a response or return. This 42-hour round trip makes real-time troubleshooting nearly impossible. Each command must be planned with extreme care, thoroughly tested and simulated on Earth before being transmitted. Engineers must anticipate multiple scenarios and prepare fallback plans, since any mistake could be irreversible. Unlike missions closer to Earth where instant feedback is possible, working with Voyager 1 demands patience, precision, and strategic foresight. Every instruction must be crafted to fix the current problem, without introducing new ones, despite the long delay in confirming whether a solution worked. The engineering team faces limited opportunities to interact with Voyager 1, meaning every command sent must be both precise and successful. There's virtually no margin for error, which makes rigorous testing and validation on Earth essential before issuing any instructions. Complicating matters further is the spacecraft's age. Launched in 1977, Voyager 1 is now over 40 years old. While it featured state-of-the-art technology at the time, much of its hardware is now considered obsolete by today's standards. The team must work with legacy systems built in the 1970s, making troubleshooting especially challenging. On top of that, Voyager 1 has endured decades in the harsh environment of space. It has been exposed to cosmic radiation, extreme temperature shifts, and impacts from micrometeoroids for more than 45 years. These conditions have contributed to the gradual degradation of its systems, increasing the difficulty of maintenance and repair. Despite these daunting obstacles, the engineering team remains dedicated to resolving the ongoing issues. They are carefully exploring different theories to identify the cause of the anomalies and running Earth-based simulations to test possible solutions. Given the risks, each step must be taken with extreme caution. An incorrect command could worsen the situation or even sever communication with the probe. Fortunately, Voyager 1 was built with redundancy in mind. Like many spacecraft, it contains backup systems that can potentially take over if a component fails. If the team confirms the source of malfunction, they may be able to switch to one of these backups to restore normal operations. One possible culprit behind the strange data is cosmic rays, high-energy particles from distant supernovae or other cosmic events. These particles, traveling near the speed of light, can penetrate the spacecraft and disrupt sensitive electronics. The longer Voyager 1 remains in space, the more likely it is to suffer such impacts. Engineers have long recognized this threat and taken steps to counter it, such as shielding critical components, building in redundancy, and using error-correcting codes during data transmission. Still, deep space missions like Voyager 1 are especially vulnerable over long durations. While the anomalies seen in Voyager 1's telemetry are troubling, they are not entirely unexpected given the spacecraft's age and prolonged exposure to cosmic radiation. Engineers and scientists continue to monitor performance closely, analyze incoming data, and develop strategies to minimize the disruptions. Despite the immense technical hurdles, Voyager 1 has far surpassed its original mission goals and continues to deliver valuable scientific insights from the outer edges of our solar system and beyond. Its enduring success stands as a testament to the brilliance of its design and the unwavering commitment of the team that has supported it for more than 4 decades. Voyager 1's journey remains a powerful symbol of humanity's unrelenting curiosity and our desire to explore the unknown. As we look ahead, missions like this continue to inspire and deepen our understanding of the cosmos.